Lesson 7, Compositions of Transformations. So we'll begin by filling in this chart. So this chart addresses which transformations will preserve distance, meaning keep all line segments the same length, meaning keeping the figure the same size, and which transformations preserve angle, meaning all angle measures remain the same size and the figure is the exact same shape. So let's begin by looking at a translation. So as we look at these translations, we see that each segment length is the same. We did not change the length of the segments. And also the angle measures. So if we look at the measure of this angle and the measure of this angle, they appear to be identical. So we can say that translations maintain the same shape and the same size. So they preserve distance and preserve angle. A reflection, we see that our segments are the same length. And we also see that our angles appear to be the same measure. So again, we are preserving distance and preserving angle with a reflection. And a rotation, the segments are the same length. The angles are the same measure. So again, we do preserve distance and preserve angle. Now, as we look at a dilation, this one's a little different because we see that the length of the segments are no longer the same. So this does not preserve distance because these two figures are different sizes. However, as we look at the measure of these angles, they do not appear to be distorted in any way. So we would say that a dilation does not preserve distance. However, it does preserve angle. They are the same shape, but not the same size. Next, a stretch. Now, this is not one that we have gone over in class, but it's a very simple concept. So a stretch is simply pulling away from the x-axis or y-axis. So you see how we've taken this green arrow and we've stretched it out. We just pulled it in one direction. So as far as preserving distance, I easily see that the length of the green line segment versus the length of the yellow line segment are two completely different lengths. So we see that a stretch does not preserve distance because these figures are not the same size. As far as preserving angle, as I look at the measure of this angle versus the measure of this angle, it is clear that from here to here, the angle got bigger. So not only does it not preserve distance, it also does not preserve angle. And lastly, a shrink. A shrink pushes a figure towards the X or Y axis. So you see how we've gone from this green arrow and we've scrunched it backwards to form this yellow arrow. So the line segments are not the same length. And the angle measures, so look at this itty bitty angle here versus this normal size angle here. The angle measures are not the same either. So again, a shrink is like a stretch. It does not preserve distance, nor does it preserve angle. So now we'll move into talking about compositions of transformations. So sometimes more than one transformation is needed to produce an image from a given pre-image. So up till now, we've only been applying one transformation to an image. So for example, we'll get an image and we'll say, let's rotate this 90 degrees. Or to another figure, we'll say, let's reflect it across the x-axis. Well, now we're going to look at applying more than one, such as to this one figure, let's reflect it over the x-axis and let's also rotate it 90 degrees. So in the lesson, what we will focus on, we will be given two figures and we will have to explain using a series of transformations how we got from one image to the other. So here are a few questions that you can ask yourself if you feel like you're stuck and can't figure it out. So the first thing you ask is, did the orientation of the figure change? Meaning, is the figure turned? Is it flipped? Does it look to be facing another direction? After you agree that the orientation is changed, then you need to be more specific and ask, has it been turned or has it been flipped? Meaning, has it been rotated or has it been reflected? After you've identified reflections and rotations, then you apply translations, because now we need to place the figure right on top of the other figure. And finally, remember to always apply reflections and rotations before you apply translations. Now we will move into our examples. For each example, we're going to describe the transformations that will carry triangle A onto triangle B. So here's our first example. So we see triangle A here, and we see triangle B here. We want to figure out how to get triangle A to sit right on top of triangle B. So I ask myself, do I think I need to turn it or flip it? Well, visually what I see, I think that I need to flip it, because I see that this point is on this side, on the left side of the y-axis, but here it's on the right side of the y-axis. So I know I need to flip this over to where this vertex is now on the left side as well. So I'm going to choose to first reflect this across the y-axis. So let me highlight my y-axis in case somebody, needs to see it. So this is the line that I'm going to be reflecting over. So this point is one space away. So I'm going to put it one space away over here. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And then 1, 2, 1, 2. So we have now reflected this across the y-axis. Now I'm almost to B. I'm closer than I was before. But now as I'm looking, I can see that I need to actually flip this again or reflect it again. So let me figure out what line I can reflect this over to get it on top of B. So as I am looking, I'm going to try to find the place right in between these two. So I see that the line that is right in between the two figures is right here. So I'm going to choose to flip over this line. So this point is 1, 2 spaces away. 1, 2 spaces away. Let me change that to the pen. This point is 1, 2, 3, 4. 1, 2, 3, 4. So far, so good. We just have to try our last point. 1, 2, 3, 4. 1, 2, 3, 4. And now we have mapped this figure A onto B. So now we need to go back and recall our steps. What was the first thing that we did? The first thing that we did was reflect across the y-axis. The second thing that we did was we reflected across this line here. And the equation of this line is y equals 2. So next we reflect across y equals 2. Now there are many ways that you could have gone about mapping A onto B. These are just the two ways that I saw, but there is not just one correct answer. There are many different ways that we could have gone about this. That's why you really have to put on your thinking cap and kind of use everything that you've learned within this unit to problem solve and figure out how to get A to B. So let's take a look at example 2. Again, we need to get A on top of B. So the first thing that I think to do is, do I need to flip it or turn it? So I'm actually thinking what will be best for me is to turn it 90 degrees counterclockwise. In class, we did have some people who reflected it over the y-axis. There are many different ways to go about it. This is just the way that I'm going to do it. So I'm going to choose to rotate 90 degrees counterclockwise. Now I have to remember that for 90 degrees counterclockwise, I'm going to change the sign of y and swap x and y. That is my function. So I need to first identify my ordered pairs. So I have -2, 2. negative 5, 2, and then negative 5, 7. So I'm going to change the y and swap. So this 2 will become negative 2. So it will be negative 2, negative 2. This 2 will become negative 2. So it will become negative 2, negative 5. This 7 will become negative 7, negative 7, negative 5. So now I have my new ordered pairs, which is my 90-degree counterclockwise turn. I'm just going to plot those points. Negative 2, negative 2. Negative 2, negative 5. And then negative 7, negative 5. So here's my figure after a 90-degree rotation counterclockwise. Now, to me, it's easy to see that the next thing I need to do is reflect. In more particular, reflect across the y-axis. So I'm just going to, I want it yellow. So I'm just going to highlight across this line so I can easily see my line of reflection. This point is 2 spaces away. So 1, 2 spaces away. 1, 2, 1, 2. And 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. And I have successfully mapped A onto B. Now I just need to recall what steps I actually took. So the first thing that I did was rotate 90 degrees counterclockwise. It is important that you identify the direction because 90 degrees counterclockwise would end up here, but 90 degrees clockwise would end us up here. So that is 2 different things. So make sure that you specify either counterclockwise or clockwise. After we did that, we reflected across the y-axis. And there you have it. These are the 2 transformations that allowed us to map A onto B. And lastly, example 3. So as I look at this one kind of reminds me of the first example. So I'm going to first try to reflect across the y-axis because I see this point over here needs to be over here. So I'm going to begin by reflecting across the y-axis. So there's my y-axis. So this would be here. This would be here. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So now I have reflected that across the y-axis. Now I know that I need to continue to move this because it's still not on top of B. So they are actually aligned. So I just need to shift it down. So if I move this down 1, 2, 3, 4, I'll be on top. 1, 2, 3, 4, and 1, 2, 3, 4. And I'm now on top of B. So the first thing that I did was reflect across the y-axis. And the second thing I did was translate 4 units down.